This how-to video looks at how you identify organic unknowns from experimental data, and it draws on knowledge understanding that you should have acquired in modules F322 and F324 of the OCR A-level syllabus. The first compound to identify, we have this information given to us, and the total mark for this question is 4 marks. The first 2 marks are for identifying the empirical formula, and we do that by looking at the percentage composition with the carbon and hydrogen. So this is just a straightforward hydrocarbon, 80% carbon, 20% hydrogen. So the first stage then is to work out what the ratio of moles of carbon to moles of hydrogen are. And we do that quite simply by taking the 80% for carbon and divide it by its relative atomic mass, which gives us a figure of 6.67. And we do exactly the same for hydrogen. We got 20% divided by its relative atomic mass, which gives us an answer of 20. So we've got a ratio of carbon 6.67 to 20 hydrogen. And we can simplify this, and the way we simplify it is to divide all the numbers involved by the smallest number. So we divide by 6.67, and that gives us 1 carbon to 3 hydrogen. So the empirical formula in this case is CH3. If we now look at section B of this compound, we have a statement about it, and it says it is gaseous at room temperature and pressure. Well, this tends to suggest that the molecular formula derived from this empirical formula is not going to be over large. In other words, we're only going to have small multiples of CH3, because the more multiples we have makes the molecule bigger, and the bigger the molecule gets, the more likely it is to move from a gaseous state to a liquid state. So the statement that it's a gas tells us that it is quite a small molecule. So let's move on to section C. Now in section C we've got some information about volumes of gases, and we have 1 decimeter cubed of compound A reacting with 3.5 decimeters cubed of oxygen to give 2 decimeter cubes of carbon dioxide and 3 decimeter cubed of water. And key statement here is that all measured at 120 degrees centigrade. Now we need to remember something about gases, and what we need to remember is that under the same conditions of temperature and pressure, equal volumes of gas contain equal number of moles. So what we can assume from this question is then that 1 decimeter cubed of compound A, well, let's call this 1 mole of compound A, reacts with 3.5 decimeters cubed, or 3.5 moles of oxygen, to give 2 decimeters cubed, or 2 moles of carbon dioxide, and 3 decimeters cubed of water, or 3 moles of water. So let's put that into an equation. Here is our empirical formula, CH3. But in this case, what I've done, I've introduced this this multiple factor called N, and that's going to reference the number of multiples of the empirical formula in the actual molecular formula. So let's have a quick look at the other side of the equation, and you can see, I hope, that we've got 2 lots of carbon dioxide and we've got 3 lots of water. So very easily we can see, well, we've actually got 6 hydrogens and 2 carbons. So if we go back over this side, I think we can see that if N equals 2, well, C2, H 3 times 2 is 6. 6 hydrogens, 6 hydrogens, 2 carbons, 2 carbons. So we end up with an overall equation which looks like this. And this is the final answer to our problem. We have an overall equation for the reaction now, involving compound A, which we now know is ethane, 1 mark, reacting with 3.5 lots of oxygen, 3.5 moles, to make 2 moles of carbon dioxide and 3 moles of water. And I've missed the state symbols out here, so if we wanted to be more pedantic, we could have C2H6 gas plus 3.5 O2 gas makes 2 CO2 gas and 3 H2O liquid. And that is compound A identified. Moving on to unknown compound B, we begin in exactly the same way as the previous example, by finding the empirical formula. And on the screen I've set out how we do that. 60% carbon, 30% hydrogen, 26% oxygen. So the ratio of carbon to hydrogen to oxygen is 5 to 13.3 to 1.67. Following the same rules and dividing by the smallest number, which is in this case is 1.67, we have a ratio of 3 carbons to 8 hydrogens to 1 oxygen, which gives us an empirical formula of C3H8O. Now section B says that this compound reacts with sodium metal to give a combustible gas, and drawing on our knowledge, we should appreciate then that compound B must be either a carboxylic acid or an alcohol. So we're going to have to write an equation, but we can't do this yet because we haven't got enough information. We don't know whether it's a carboxylic acid or an alcohol. Let's look at section C and D together. So section C tells us it doesn't give any effect with universal indicator solution, so it's obviously not an acid. So it must be an alcohol, because in section B we've said it's a carboxylic or an alcohol. In section C we know that it's now neutral, so it must be an alcohol. And then section D tells us that, well, there is no reaction with 2,4-DNP, which, if we recall, 2,4-DNP is our standard test for a carbonyl, an aldehyde or a ketone. So that's really confirmed that we do have an alcohol. It's not a carbonyl compound, it's not a carboxylic acid. Section E enables us to draw all this together, because it tells us that when we reflux compound B with sodium dichromate, we get an orange precipitate which is not acidic. So compound B must be being oxidized, and it's being oxidized to a product which stops it stops before it basically gets to carboxylic acid. So what does that tell us? Well, it tells us that compound B must be a secondary alcohol. If it was a primary alcohol, what would happen is it would continue under reflux to become a carboxylic acid, and section E says it is not acidic, the product is not acidic. So the oxidation happens but stops at a carbonyl compound, and the only way it can stop at a carbonyl compound is by being a secondary alcohol. So in summary, section E, we have our secondary alcohol being oxidized, and this is the standard way of writing oxidation occurring with the dichromate, acidified, to form a ketone. And the R groups refer to carbon chains. And now we look back at the empirical formula, and if we move on, we can now write the equation that was required in section B. So we have our secondary alcohol reacting with sodium metal to make a salt and releasing the combustible gas, which is hydrogen. And because we've only got 3 carbon atoms, the only form of secondary alcohol that we can actually produce from this empirical formula is for propane 2-ol. So compound B is simply propane 2-ol. The next video in this how-to series will look at how to identify the remaining compounds in this worksheet. Thanks.